Okay, let's look at the homework 4.7, number 5. All right, so you have a wire that is 6 meter long. So you have a wire. So the whole thing is 6 meters. All right, then we're gonna cut it somewhere. And the first portion, let's say you have x meters. So x meters. And the other portion is going to be, of course, 6 minus x meters. So 6 minus x meters, right? And for the first portion, first one, you're going to make a square. So you have a little square, right, using x meters. So each one is going to be x over 4. So x over 4, then you have x over 4, right? So the area here is going to be x over 4 times x over 4. So area of the square would be x squared over 16. Right? Then the other portion is it's going to be a circle. So we're going to make a circle using the other piece. All right, and to find the radius, we have to solve this equation. So circumference of the circle is 2 pi r. And this has to be equal to 6 minus x. So we can see that radius r is going to be 6 minus x over 2 pi, right? So the area we want to find is the area of the circle, so right here, right? So that's the area, would be pi r squared. So it's going to be pi and r squared. So it's going to be 6 minus pi quantity squared over 2 squared would be 4, and you have a pi squared, right? But there's pi here and a pi there, so cancel those out. So this is going to be simply quantity 6 minus x squared over 4 pi. All right. So the area is a combination of those two areas, so we have to add them up. So we're going to have an area function. Let's call it a of x, which is equal to x squared over 16. Right, that's one of them. And then you have quantity 6 minus x squared over 4 pi. Right? Then x can move from, so x could be, you don't have to use any for the square, so can start from 0. And all the way up to, of course, 6. Entire wire is 6 meters, so you can go up to 6 meters. Then for A and B, for A we have to maximize and we have to minimize this area. So we have to do both. So we need to maximize and minimize this area function. All right. So let's look at the derivative and find a critical number. So a prime of x is going to be equal to, all right? So 1 over 16 is just a constant, so I'll just put over 16 here. Right? Derivative of x squared would be 2x. Right? Plus, right? 1 over 4 pi is just a constant, so we leave it there. Then derivative of that is put 2 in front. Keep the same quantity, 6 minus x. And a derivative of that would be -1. Right? And subtract 1 from 2, you get the first power. All right, then you can cancel 2 and 16, and you can get 8 here. And 2 and 4 cancel out, so it's 2, right? So what you get is, let's see, you have x on top over 8, right? Then here is going to be, I'm going to incorporate the negative sign, so it's going to be a plus, right? Negative x would be positive x. Negative 1 times positive 6 is minus 6, right? Then on the bottom you would have 2 pi, right? Then I need to combine these two fractions by taking a common denominator. So a common denominator would be 8 pi, right? So I need to multiply x by pi, so it's going to be pi x, right? So in order to get 8 pi, we have to multiply 2 pi by 4, so I have to multiply numerator by 4. So it's going to be plus 4x minus 6 times 4 is 24, right? Then group the x terms together, we get pi plus 4 x minus 24 all over 8 pi, right? Then we set that equal to 0, right? But we can just set the numerator equal to 0, so we can get this critical number. X is equal to, right? So it's going to be 24 over pi over 4. So 24 over, sorry, pi plus 4. Sorry, I said pi over 4. Pi plus 4. Right? So this is the critical number. All right? Then let's do a derivative analysis so that we can find where the max is and where the minimum is. So let's do a number line from 0 to 6. So 0 is here, and 6 is right here. And now 24 over pi over 4 would be somewhere over here, so I'll just put it here kind of randomly, but it's going to be less than 6. 24 over pi plus 4. All right. Then we look at the sign of a prime, right? So sign of a prime. So we're going to try something smaller than 24 over pi over 4, like 1 or something like that. So if you plug in a prime of 1, 1 I meant, oops, sorry, can't write, here's 1, right? So if you plug in 1 here, you're going to have pi plus 4 times 1 minus 24 is negative. So this is negative here. So on this interval, a prime is negative. Right? After this number, you can try like 5 or something like that. So pi plus 4 is about 7.14 times, times 5 is going to be much bigger than 24. So it's going to be positive. So a prime of 5 is going to be positive. So on this interval, derivative is positive. All right. So we can at least where the minimum is going to be, because decreasing turn into increasing. So here is the minimum value occurs. So minimum value is going to occur at the critical number. So the part B answer is easy. So x is going to be 24 over pi plus 4, which is the right answer right here. All right, then since it's decreasing turning to increasing, so it's going to be either at x equals 0 or x equals 6, you have the maximum. So we're going to have to compare them. All right, so let's look at a of 0. So that means that you use the whole thing for the circle. So plug in 0 here, plug in 0 here, so it's going to be 6 squared. So it's going to be 36 over 4 pi. right, which can be simplified to divide by 4, you have 9, and divide by 4 there, so it's a 9 over pi. All right, then we have to look for something bigger than that. So is this bigger than this? All right, a of 6 is going to be, all right, so we're going to use the entire thing for the square. So 6 squared would be 36 over 16, right? Divide by 4, 9, divide by 4, so it's 4. So you have a 9 quarters, all right? So you have the same numerator, and pi is 3.14. This is 4. So you can see that this is larger. So you have a maximum here, right? So we're going to use actually no wire for the square to maximize the combined area, right? That's the right answer, right? That's it. I hope that this was clear.